Hello, I'm Anna Mackay. What's your name? Lovely to meet you. Speaking of meeting, today we're going to talk about where functions meet. So there's three types of scenarios that can happen here. If we have two functions, we may have a quadratic, a parabola for one, and we may have a straight line, a linear for the other. Doesn't really matter. There's three versions that you could have. They could cut each other, which means that they would meet twice. They could touch each other. Do you know the special name for a straight line to a curve in this scenario? It's called a tangent. T for tangent, T for touch, if you like. And so they meet once. And then the third scenario is that they don't meet at all. And so there is no point of intersection. And that's going to have particular connections with the discriminant that we've done some work on. And in terms of there would be two solutions, there would be one solution, or there'd be no solutions in these scenarios. Okay, a couple of examples. If you're asked to find the coordinates of the points of intersections of the graphs with these two equations. Now my tip is, while you've got your graphics calculator, graph them both. See what they look like and see where they meet, and so you've already got an idea of what answer you're going to get, so you'll know if it's reasonable or not. Now algebraically, how do you do that? You essentially put y equal to y and find where the y's are equal. So let's do that. We've got x squared take x take 18 is equal to x take 3. And we're going to solve for that algebraically. So how to do that? You need to rearrange so that the right hand side is equal to 0, and essentially you could use the null factor law then. So rearranging, you can do it in whatever speed that you're comfortable with. Notice the sign changes, and now I'm going to collect like terms. X squared, there we've got negative x, take away another x, so we've got take 2x, and then the constants, negative 18, add on 3, brings us to negative 15. It's equal to 0. So you can always just jump straight to the quadratic formula to solve these. But some of these easier numbers, it's probably worth having a look at the factors. So two numbers that multiply together to give 15, got 1 and 15, or 3 and 5, and taking into account that one of them will be negative, can any combination of that give us negative 2? It can actually. There's a couple of ways to solve this. There's the cross method or the splitting the middle term, whatever works for you. One way I got taught in year 10 was like this, a cross method. So looking at the 15 there, the factors are 5 and 3. One of them is negative, so I'll put the negative on in a minute. But to end up with a negative 2, so looking at adding and subtracting these numbers, we're going to end up with a positive 3, take away 5, that would give us the negative 2, and then they are your linear factors. So you read off horizontally, and we've got x take 5 and x plus 3. So solving for x here, these are the points where they meet. They meet when x is 5 and negative 3. But it asks for the coordinates, which means we need the y values that match these x values here. So you substitute those values in. So if you sub x is equal to 5, you might ask yourself, where do I sub it into? You've got two choices. You could sub it into that function or this function. Which one might you pick? I'd pick that one because it's easier. Being linear, you have less possibilities of making a mistake. So where you see the x, you're going to put in the 5. 5 take 3 gives us 2. And as coordinates, don't just leave it like that. X is 5 and y is 2. And then the second one is sub in, what have we got? Negative 3. Well, it's x is equal to negative 3, I should say. So y is equal to negative 3, take 3, that's equal to negative 6 as a coordinate, negative 3, negative 6. Go back and check the question, find the coordinates of the points of intersection. Check, we've done that. And the next one, now we've got two equations here. We're saying that this is a tangent, so it's a straight line to this curve. And we have to find k. So there are a few pieces of information in there. The fact that it's a tangent, so that's going to tell us about how those curves, those functions interact with each other. A tangent means it's a touch. So they're going to meet once, they're going to have one point of intersection, and it's going to be a repeated root. So I'm going to go into more depth with what I mean there. So the same technique is the same. You put this function equal to this function. I'll put the quadratic on the left because when I come to solving, that's the power order that we want. We want everything on the left, equals 2x plus k. So once again, you rearrange to get the right-hand side equal to 0. And you could put the like terms next to each other straight away if you prefer. Let's have a think about this. This is our only x squared value, so that's going to stay there. We've got minus 3x and minus 2x, so we've got a minus 5x. Now, thinking about what's left, plus 4 and a minus k. So that together makes our constant term. So put a plus there, but then group them together. 4 take k. In brackets, it'll help you see it more clearly. How are you going to find k now? Using this piece of information about the tangent and the touch. This is where information about the discriminant comes in handy. So the discriminant is actually going to be equal to 0 because it's a touch. So remember, it's got one point of intersection. Now, what is the discriminant? We've got b squared minus 4ac. Well, what is our a, our b, and our c? Where do they come from? They don't come from up here. They come from this equation where they meet. So our a is 2, our b is negative 5, and your c, don't be put off by this, is that whole component there, that whole expression, 4 take k. So now we're going to substitute them in and put this equal to 0 because that tells us about the touch. And so we substitute in b, minus 5 squared, take 4ac, make sure you've got brackets, and it's equal to 0 because they have one point of intersection, a touch. Simplifying and solving for k. So working out the factors here, so 4 times 2 is 8, 4 take k is 0. Keep solving for k. Okay, so what could you do here? You could expand that bracket to get negative 32. Notice it's plus 8k there. Watch your signs. Just going to take this over here because I'm running out of room. 25 take 32 gives us negative 7. Negative 7 plus 8k is equal to 0. Keep solving for k. Move that 7 over, and k is equal to 7 on 8 if my screen catches up. Go back and read the question. We needed to find k. So excellent, we've done that. Okay, that's this video. Make sure you give it a thumbs up and subscribe to the channel. And the next video in this series, if my screen catches up, is called Problem Solving with Quadratics. Thank you.